Thanks, everyone. So in the spirit of thinking about that we're playing a long game of building capacity in the state and awareness of NGSS, and that we have some time because the standards aren't going to be passed like right away, I offer this as a kind of workshop on assessment and NGSS. Because many of you are teacher educators, prepare teachers in various contexts in your work, all of the activities I'm doing here are ones that I'm kind of assuming you're thinking about how could I go back and do this with the teachers that I work with. So it'll be a little accelerated compared in terms of the time that I'm going to give you for the tasks that I would recommend to give teachers, so that you can see more kinds of activities to do. But this sequence that I'm going to go through is one that we've tested and tried with about 90 teachers this spring at NSTA as part of a professional development institute. And we're repeating that on the first day of NSTA. And that's an all-day PDI. So if you have teachers who you know are going or you'd like to come, encourage you to come for that. So a little bit of the itinerary for today. I'm going to give an overview of our National Research Council report on assessment and NGSS. We're going to go back and look at the framework to develop evidence statements. We're going to and that's one of the first activities that I would encourage folks to do with teachers. Another one is we're going to compare and contrast existing assessments for the same performance expectation, which really helps people with only a general grasp of the NGSS and the framework to pretty much immediately see, oh, I get the differences here, what's being asked. And then we're going to try our hand towards the end at redesigning assessment, and if there's some time, I encourage you to ask questions along the way, but I'm going to try to build in 10 or 15 minutes at the end for Q&A. So a little bit of context. As Leslie mentioned, I was served on a committee that developed the NRC report that came out last year called Developing Assessments for the Next Generation Science Standards. We started meeting before the first draft of NGSS was developed. So in very much we were guided by this image here, which is in the framework of the 3 dimensions of science learning, and this notion that what we are after is assessing integrated science learning, or 3-dimensional. We use the term 3-dimensional science learning, where we look at disciplinary core ideas, cross-cutting concepts, science and engineering practices, and set out as our task to try to understand what would it look like to have assessments and an assessment system that could monitor progress and inform instruction under NGSS. But I mentioned the timing because you're going to see me go back more to the framework. And I actually think that's a really good move in general. One is that I think for elementary there's still a lot of mismatches between what ended up in NGSS and maybe what people like and love about the framework. So asking secondary versus elementary folks what they think about NGSS is a very different experience when I go across the country. So I think I'm going to encourage, and that's also safe political territory wherever you are, to go back into the framework for inspiration. So our charge was to make recommendations for strategies for developing assessments that validly measure student proficiency in science as laid out in the framework. So note that goes back to that was our charge too. Also to review the recent work on assessment for innovations and evidence of good practices in assessment, and to try to think about what would be the components of a system of assessments, and I'll say a little bit about that, what we ended up recommending that for the framework's vision that could be assessed, and also to look forward. What needs to be done going forward? Because one of the things that I can't underscore enough is that what we were trying to do with assessing 3-dimensional science learning is unprecedented from an assessment research standpoint. It's stumping the psychometricians, if you will. It's like it's a hard problem for everyone involved. So there's a lot to be done, and part of our big recommendation was move slowly, because the field has to catch up with where we want to go in the policy arena. So don't rush out and create accountability tests next year was one of our recommendations. So I want to underscore, I assume people are familiar with the framework, but I like to go back to the principles of it and remind folks of, like, because they're so fresh and important and they drive everything all the way to NGSS. So the one is this idea of children being born investigators. And this is to counter deficit views of kids as not beginning with a lot to begin with and to an overemphasis on misconceptions that kids bring. So it's really remembering we have to begin where kids are, and there are many productive entry points in their everyday experiences we can draw on. Focusing on core ideas and practices is that this is about deep exploration of important concepts to counter the mile-wide, inch-deep curriculum, as well as times to develop and actually practice, engage in science and engineering practices and reflect on the nature of those practices. Understanding develops over time, that really this is going to take multiple encounters, that there are 16 disciplinary core ideas across all of K-12. So there is both the need and opportunity to coordinate across grade levels for how we're going to support science learning within schools, within districts, at the state level. To really think about how to take that seriously is to recognize we're going to keep revisiting these, and it's going to get deeper and deeper over time. Requiring both knowledge and practice to get away from the idea that it's just an 800-pound textbook and definitions that appear in that, but really that science is both a body of knowledge and a way of generating new knowledge. Connecting to students' interests and experience. If we want to broaden participation in STEM, we absolutely have to captivate students' interest. And we have to think about that as drawing on their cultural and community funds of knowledge and finding out what are your interests, what are the relevant experiences you bring. Focusing on equity means the standards are for everyone, and we have to make sure that the resources and opportunities to learn are there for everyone. So these map on to our recommendations. I just highlight a few here for that. I'm going to back up. I'm sorry. I'm blocking you guys' way. One is that, assessments need to actually, we need more pre-assessments to find out what are those starting points for instruction. That's the only one on here that's not tied to a specific recommendation. In terms of focusing on core ideas and practices, one of our big emphases is it's going to require professional development for educators, I would say teacher educators and assessment designers and psychometricians too. That these are difficult to design, these kinds of assessments is one of our recommendations. In terms of understanding develops over time, because it develops over time, we need to think about accumulating a body of evidence that accumulates over the school year, across school years, from multiple kinds of assessments to really understand how kids are progressing. It's important to note and underscore that the performance expectations in NGSS are the end of a process. There are many steps towards them that are going to be necessary, and we need evidence along the way to help understand how kids are developing. In terms of this requirement of knowledge and practice, the scoring rubrics and the reports, it's really important we not just separate back out inquiry and content in how we report, because we all know very well from our accountability systems, once we start reporting that back out, that's how it's going to get taught. And it's going to undo the very vision of the framework of integrated science learning. So thinking about how we develop rubrics by tasks that provide really an inference about the performance expectation as an integrated statement of what kids know and can do, as opposed to content over here and practices over here. And that's hard. Connecting to students' interests, teams have to include, like we have, one of our recommendations is that we need understanding of cultural diversity on assessment teams. I would add something we didn't recommend, but as an example in our chapter, we don't normally think of a function of assessment as eliciting students' interests. and their cultural funds of knowledge. So, but we could do that, and that is actually that is a type of assessment. That's partly what our proposal that Leslie and Sam and Joe and I've been working on, is to really develop out what would it mean to try to make that part of assessment, so that we can build curriculum units that really do resonate with students' interests. Promoting equity, we have strong recommendations about the need to monitor opportunities to learn. It's not enough to have just outcome measures. We need practice measures. What is going on in classrooms? And also, do teachers have adequate resources, curriculum materials that are aligned, and professional development opportunities? So I highlight our recommendations very quickly in light of the principles, because to me the principles are, it's going back to the framework, but also really going back to these principles is key. So what is the nature of the assessment challenges? I kind of frame them as three big questions. How the heck do we assess three-dimensional science learning? Because it doesn't look like most of our assessments today. And so I want to underscore how, how is it different? And then how do we actually design tasks? So that's why I want to engage you all in thinking and some tools for how you might do that. Part of what makes this a challenge is there are all these learning progressions in the NGSS, and there's a lot of arm waving about how they're research-based. Well, most of them are not. So most of them are not, and the ones that are don't necessarily have assessments attached to them. So basically those have to be invented, and they're hypothetical. So the examples of completely aligned tasks, Jim Pellegrino said in 2013, don't exist. I would say we're on our way, towards thinking about that. The other piece is that, although I think one of the advantages of performance expectations is that they go beyond the statements that begin, students shall know that, and then you wonder what would it mean to know that, to really clarify what proficiency means. They're still not sufficient to guide everyday instruction, because those are intended to cover either a whole year or in some cases an entire grade band of middle or high school. So they're not yet enough in providing guidance to designing assessments. So one of our recommendations is that we think that states develop systems of assessments, and that means a range of assessments that answer different questions. Part of why we have the problems that we do with today's accountability systems is that we try to make one state assessment do all our work for us. That's bad assessment practice, and we basically end up trying to get information from state tests that it can't possibly inform instruction. Because they're too broad, we don't actually have a system in place of what actually kids received in the way of instruction. It's interesting to think about building a system that only monitors outputs when the hope is that you're going to change the process going on. And we call it data-driven decision-making, but we have no data on the process that we're trying to improve. Those are our accountability systems today. So that's why we say we have to have measures of opportunities to learn. So those assessments need to support classroom instruction, monitor science learning at school, district, state level for both individuals and organizations, a series of indicators that really are provided with adequate opportunity to learn. Those are key goals that have to be met. I think I can't underscore this first bullet point enough. We said quite explicitly in our report, it is not possible. It is not possible to assess all the performance expectations with a single system of a single external test. So when you hear people complain we can't have assessments, you said, point them back to our report. Say, we actually said you shouldn't try this. Not one standard, one item, every grade, every kid. We said that isn't workable, because it will undercut our vision given the budgets that states can spend on assessment. Types that are needed take time to administer, and several are going to be required. One of the enduring issues from the last generation where states tried to do performance assessment is, yes, they're great, but if a kid messes up one of the 5 tasks and doesn't do well, that can be deeply consequential and turn out, oddly enough, to be less fair than the multiple choice test. because that were spread across different content. Because maybe they don't have access linguistically or culturally to the particular prompt or task context that other kids are able to take advantage of. So it's a serious issue to think about. I need lots of performances if I want to make an inference, a valid inference about an individual student. Some of these practices are going to be difficult using conventional formats of on-demand external assessments. You know, how would you plan and carry out an investigation in a pencil and paper format? That's going to be pretty hard to try to do. In terms of the opportunity to learn, some things that we said is that if you think about it, if you want kids to do science, how are you going to find out if that's actually happening in the classroom? You have to observe. You have to have some way to document practices. Some of the things that we laid out that are possible, a lot of people are intrigued by, in the assessment community, inspectorate systems in the UK Commonwealth countries from England to Australia to New Zealand, which have a very different notion of monitoring that comes in. There's a lot of accountability that is internal accountability within schools until you don't meet a certain threshold, and then that triggers a monitoring system that's intended to be assistive. Surveys of students and teachers in terms of engagement, you know, what kinds of opportunities to learn that both students and teachers have. Did teachers have adequate access to PD, for example, through surveys? Direct monitoring of PD programs. Are they providing these opportunities that we really need? Are they sustained, focused on the practices? Documentation of curriculum assignments and student work to look at, you know, how demanding are the curriculum opportunities that kids actually receive. That's part of getting that. And again, I see the opportunity to learn as a really important equity component, because part of the problem with having only outputs is we don't know what the inputs and the processes were and whether the kids actually got the opportunity to encounter really demanding, rich instruction in science. And that's so key. If we don't know that, how can we make a judgment about whether that achievement gap is an achievement gap of the individual versus an opportunity gap? So this is our other biggest piece, and this is kind of, I'm going to start segueing into like the focus of this work, because I think our biggest first hurdle is to think about what it means to design what we call multi-component tasks in the report. And the assumption here is that tasks have to cover multiple components. That is, that they're a set of interrelated questions. We might need to know something about whether a student understands the disciplinary core idea apart from their skill in engaging in a practice, but we want to get to, in order to be able to sort of say what part of this performance expectation they get. It's just hard to have one big integrated question. Even if you present kids with a generic scenario that integrates all these dimensions or demands it, one of the truisms of those of us who do a lot of assessment development work is totally unscaffolded items like that end up yielding a lot of uninterpretable results. So, like, I see smiles in the back of the room, people who look at kids writing all the time. You kind of need some structures along the way, even for a very open-ended task, to kind of check and help guide students along in a subtle way, but also get information about how they're thinking, and lead them not towards things that might be not what you're actually interested in learning about, whether they know and can do. So that is kind of the big task, and some of these happen in classroom assessments. So the chapter that I was involved in writing heavily has several examples that I highly recommend looking at from different classes. So I wanted to show you an example of a multi-component task that is not just on paper, but it lives in the room too. And it's actually a sequence that looks a lot like just an instructional sequence. Because at the end of the day, if you have people who can write good multi-component assessment tasks, they can also make good curriculum adaptations. Like I think this is a key strategy for curriculum adaptation and curriculum writing, because teachers are going to be doing a lot of curriculum adaptation and writing over the next few years, because there's no budget, and we've got a long way to go with our elementary kit-based programs in terms of, bridging the gap between the vision and what those allow. So the example I'm going to give is some work that my colleagues and I did in collaboration with DPS. In the, I don't know, we concluded that work about 2 or 3 years ago. And this is one that integrates, it's a set of assessments that integrates with the Investigating Earth Systems middle school curriculum. How many of you know that curriculum at all? So it's a handful. So it's an NSF developed curriculum that it's modular, it has many earth science units. It is organized around a series of investigations. If I had to say anything that was a weak point about it, it's the sense-making element that is so important to science of connecting, like, why are we doing this investigation? How does it map back on to the Earth system that we're trying to have kids understand by doing that? So in a sense, our assessment project, which was funded by NSF, was both to assess and to help kids through reflection on learning make those sense-making connections themselves. So this is an example of, I think, one and it appears in our report, NRC report. So it leverages, I know since we're at CU and we do a lot of this at higher ed, this leverages the power of clicker technology. So it begins with a set of clicker questions, and this activity, that's the initiation of the task. So there's a picture of the Nile Delta on the left, doesn't quite show up, and a fan on the right. So the green areas show a place where a river flows in the stream. Why does this look like a triangle where it flows into the ocean? Be prepared to explain your response. These would be like a review cycle after they've gone through an investigation around deposition. And each of the answers I'll say a little bit more about. It's based on, but we did some preliminary work with this as an open-ended STEM to find out what the most common responses to the students' questions were. So they're not arbitrarily chosen, they're not chosen to trick kids. These choices are common ideas, one of which is the right idea here, but then the other 3 are ones that are pretty common that we get. But it's not just click the question, answer, and move on. Part of the task is to follow what we call a pedagogical pattern. And this particular pattern that I'm sharing is modeled after peer instruction, which is a higher education in physics pattern. So teachers would pose the question, students might discuss their responses in pairs and small groups. This is really important for argumentation and discussion in NGSS from an equity standpoint, to be able to have multiple formats, especially for English learners, to sort of get their ideas on the table. So jumping into whole group discussion first was something we wanted to avoid, but really give multiple formats. But then in the whole group, the teacher would walk through each of these responses and say, now why might somebody answer A? And so each answer is positioned as worthy of consideration, very purposefully, and there are follow-up questions. So we worked with, you'll see it in Ready, Set, Science, Sarah Michaels' talk moves. And so we had teachers had a set of talk moves they could use to help orchestrate the classroom discussion. And in their notebooks, these were physical, those talk moves just sat right opposite a page with the question on them. So they had those kind of in the back, they're like back pocket questions. And then students would, after an argumentation, students would re-answer the question. And depending on their answer, students might, we might either have most of it, we might be able to move on because most of the kids get it, or I'll show what happens next. The other resource, though, is, so I mentioned that this is underlying, this is a theory of cognition called facets-based instruction from Jim Minstrel. So that's how we developed the initial responses. But we also, these are too small to see, but this is a set of resources teachers said about like what kids might be thinking, for what they could listen to in the response. And that's important for this, learning develops over time idea in the framework. So just to connect that back to that idea that we have an underlying theory of how kids' ideas develop over time. So if the kids had trouble, we had a contingent activity that had its own pedagogical pattern that would be fit within the developing and using models. So in this case, students, this is the end of that cycle, but students would actually, we relied on a lot of the Turk animations in the class zone that are available that developed, I forget which project of theirs that was. And people, like, they basically try to understand what's happening. They view that animation, and then at the end they have to make like some predictions about using a model of how water is flowing. So this is a way to try to say, what's the other way in? It helps with our whole project was oriented towards the what's next problem, so I know that kids don't understand the idea. Do I repeat the exact same thing that I did just a while ago? Like, I need an additional resource. Not only did I need an additional resource, I need a different way into the same content. So the contingent pedagogies complemented, all of the contingent activities are intended to complement. So how is this an example? It's got multiple components. There's a clicker question, there's a pedagogical pattern to be followed, contingent activities. Notice it's not all on one sheet of paper even though the ones we're going to look at today are that. The disciplinary core idea, I would say our clicker questions, they predate the framework. We were really after the DCI. But the second that the students have to defend their ideas, we were trying to support the practice of argumentation. And the class activity and discussion were really about developing and using models in terms of the contingent activities. In terms of the cross-cutting concepts, one of the other things in the contingent activity, the very first step is to always involve some review of what is involved in modeling a system. So they're having the invitation to make connections across different content areas about, okay, here's a model here, here's a model here. What are similar about or different about these models? So that's an example of that. And before we transition into doing some activities together, I'll just see if I'll take like 3 or 4 minutes for some questions before jumping in about our report framework. Yeah, Rebecca.
Are you going to talk more later about the issue of the use of the assessment? Because I think that's a really important topic.
Not today. I mean, I think if we can, partly as I'm thinking about today, beginning points. Where do we start the work? So if we get to the point where we can even design, my thought is we can get to our point where we can design 3-dimensional tasks. We've really advanced assessment goals, but also curriculum adaptation goals. Obviously, usage is a huge, that was a core problem that we tried to take up with contingent pedagogies. What did you do with the data? But giving teachers some guidance about that. Other questions? Ready to jump in? Okay. So I'll have to figure, we're going to kind of spread out to these 2 tables, and I'm not sure, let's see. I think we'll probably have you in a minute. Well, let me set this up and then I'll get us into breakout groups. So we're going to focus quite a bit of work today now on this one high school performance expectation. I picked it because I had developed a number of resources around it for our work in Denver that we're doing right now to develop an ecosystems unit with teachers. So this really pertains, in the old way you would say, well, this is the topic of carrying capacity. But notice like what it's asking. So use a mathematical or computational representation to support explanations of factors affecting carrying capacities of ecosystems at different scales. So a first step, if you want to write a set of assessments around this, and the first caveat is you might not have one set of tasks around just one performance expectation, but it's going to simplify our task today to do that, is to develop what we'll call evidence statements. And we're going to dive deep into the framework to identify the core components that are part of this, and I've got some handouts that have the pieces of the framework that you will need for this task. And what we're going to do is try to turn this into student-facing things. What would you see kids saying or doing that would give you some confidence that they could do this? Because the statements are kind of abstract about what kids should know and can do. So what would you see and do? This is before you think about what kind of task you're going to present. And because what you want tasks to do is to elicit those sayings and doings of kids. So it seems like this extra funny step, but it's so important to do. What am I going to see students doing? And I want you to focus on some of the aspects of performance that are likely to reveal different levels of understanding. Think about, like, how would you know kids doing well versus not well? And perhaps in your groups, spend a little time focusing on filling in the middle. You will see in the framework there are 8th grade expectations and 12th grade expectations, 5th grade expectations. So focus on that. What's the gap between, in this case, 8th and 12th grade? What do you notice is different about those expectations that might need to be developed to cross that gap for kids? So, and I'll just add about this task. Achieve is busy developing evidence statements for the NGSS along the lines that I'm having you do this activity. So they may come up with some slightly different resources than I might create, and I think they're doing the sense-making work for you, but the reason I'm having you do this, I think this is a great way to get teachers back into the framework and thinking hard about the framework. So yeah, eventually you'll be able to go and look up these evidence statements on Achieve's website, but that's sort of taking away the learning opportunity here to really go dive in deep. So I think what I'm going to do is I'm going to have you find, let's see, it's probably good to work in groups in 3 and 4. And I will stand over there and I'm going to hand, you're going to get one of three things. We'll jigsaw at the end in the third activity. So one group, like I'm just going to hand a group, and the next group is going to get, one group's going to get the practice, the next group's going to get the core idea to go deep, the other in the cross-cutting concepts. And you will have a handout too that everybody, I think there's enough for everybody here to fill out around the evidence statements. You'll only fill out your portion for your group thing. So I want you to take, good 20 minutes just to really sink in and try to wrestle with this task, and then we'll spend about 10 minutes just coming back together and debriefing that a bit.